All right, so we're going to go ahead and go through 34 to 47. So first problem says factor it. Hopefully you feel pretty confident on this. So factoring, this is just take factors of, your C is negative 12. You want to find the factors that add to negative 1. So that'd be negative 4 and 3. So we write it as x minus 4 and x plus 3. That's the factored form. And then remember, the zeros are what makes those each factor equal 0. So 4 would make this one equal 0, and negative 3 would make that part equal 0. You could certainly graph it and see where it crosses as well. That's the same thing. The zeros from the equation match the x-intercepts on the graph. This one says use square roots to solve it. So I subtracted 49 over. That was my first step. And then I just had x squared here, so I square rooted both sides. And then I asked myself, what's the square root of negative 49? Well, the square root of positive 49 would be plus or minus 7. So if it's if it's a negative, it's just going to change to plus or minus 7i. That's pretty much how imaginary numbers work. When you're square rooting a negative number, everything else is the same. It's just going to make your answer imaginary. Sums are probably the easiest. It's just straight up combining like terms. 4 plus the negative 5 makes the negative 1. That's your real part. And a negative 6i plus a 13i makes 7i. That's the imaginary part. Don't overthink those. Product, we did it in the warm-up today, but same process. We go through and do our distributive property. We should get 4 terms out of it. And then we remember this is always equivalent to negative 1. So in this case, the imaginary parts ended up being opposites of each other. So they dropped out altogether, and we just got a real number answer. But sometimes, like in the warm-up, you will get one that has a real and an imaginary part. Same thing with 38 here. Division. You'll notice we did the same move. We took the conjugate of the denominator, which you just changed the sign of the imaginary part. So it's 1 minus 2i, 1 minus 2i. Distribute this out, and see how things simplify. This one happened to simplify really nicely because you ended up getting a 5 on the bottom that just evenly divided into both of those. Okay, so same process as we did in the warm-up, just a little bit different numbers. 39, if you know the trick, super easy. It's a sum of squares. It's something squared plus something squared. So this is 4x squared and this is 5 squared. So it's going to be 4x plus 5i and 4x minus 5i. Oops, left my parenthesis off there. In the warm-up on Friday, we talked about this exact scenario that anytime you're adding 2 squares, you're going to get imaginary factors. If this was a minus, it'd be the same thing. There just wouldn't be i's. So if this was 16x squared minus 25, this would be 4x plus 5 and 4x minus 5. So if you remember your sum and difference of squares problems, they are the easiest ones to factor because they just have a nice little rule you can follow. All right, on to 40. 40, we've got quadratic formula. Certainly going to see this on there. And this just really breaks down to, can you substitute the numbers in? So like A is 1, B is 3, C is 4. Those go in your quadratic formula. And then you simplify things. Generally, if people have trouble, it's usually simplifying this root. So we got 9 minus 16, which ends up being negative 7, which 7 doesn't have any perfect square factors at all, but we can at least pull that negative out as an I. And that's all that we can simplify here because these aren't divisible by 2, so we just leave our answer like that. We did a couple of those the other day too, so again, hopefully you're feeling pretty decent on quadratic formula. Then it goes into the discriminant. If you forgot about the discriminant is just the part that's under the root. It's the b squared minus 4ac, so that's called the discriminant. And what it does is if you calculate whatever the discriminant is for an equation, depending on whether it's positive or negative or 0, tells you what kind of solutions you're going to get. So in this case, I took my a, b, and c, and I just did the discriminant, and I got 81. Now that 81 doesn't tell you 81 anything. 81 is not the solution. 81 is not anything to do with the problem. The fact is, it's a positive number. And since you're taking the square root of a positive, that means you're going to get 2 real solutions. If you work this out and you get a negative, then you're going to get 2 imaginary solutions because now you're going to be taking the root of a negative number. And if you happen to get 0, it doesn't happen very often, but if you happen to get 0, that means you're going to just get 1 real solution because it just touches the graph at one spot. So all the discriminant does, it does not tell you the solution. The answer to this problem is definitely not 81. Okay, it just tells you the number and type of solutions. In this case, 2 real solutions because we got a positive number. Okay, so don't overanalyze that. It simply indicates what kind of solutions you're going to get. 42, another quadratic formula one, kind of like the other one. As we get everything plugged in and we go to simplify this root, we got a 29 under here, and that doesn't break down any further. 29 has no perfect square factors. 7 and 1 are not divisible by 2, so you can't really do anything with it. You just, boom, leave it as that. Those are my 2 solutions. So then if we keep on rolling here, we get down to 43. So this one is intended to be done with a discriminant. There was one like this on our quiz back when we did this section, and people had some trouble with this. So they're asking you, does this equation for height ever reach 12 for this this toy cannonball? So it's shooting something, but this is the path that the ball follows. It goes up, comes down, and they're basically just asking you, does it ever reach a height of 12? So wherever 12 is at on this graph, is it here? Is 12 here? So is it hitting it or not? So what I did was I took my equation, I set it equal to 12. That's what I'm trying to figure out is, does this ever equal 12? And then I just moved it into standard form. So I took this, subtracted it over. So now I have a standard form equation that if this has a solution, it means that it does hit 12. And if this doesn't have a solution, then it means it does not hit 12. So the simplest route to just know if something has a solution or not is to do the discriminant. So I took my B, my A, and my C, substituted them in, and worked it out. And so I got 240. Again, 240 does not mean anything about the problem. It doesn't hit a height of 240. It doesn't take 240 seconds to do it. It's nothing. 240 has no implication with the values of the problem. It simply is an indicator. Since it's a positive number, it means that this has two real solutions. In other words, the ball goes up and comes down, and it does pass a height of 12. It passes it twice. It's got two different times when it hits 12. So that's the answer to the question, is simply a yes, it does. And we use the discriminant to figure out that it did have a solution. Now, if you work this out, and let's pretend this was a negative 240. If it's negative, it means it has two imaginary solutions. Then you'd be like, no, it never does. That would be this case. That'd be where it doesn't intersect the 12. Okay? You could graph it and take a look at it too. Just tips to keep in mind. 44, more discriminant stuff. So this is saying, what would this B value need to be? Notice how you know A and C, but you don't know B, to make it have one real solution. So by our rules, one real solution is when the discriminant is 0. So I took my discriminant equation and set it equal to 0, because that's what this is telling me. So the B is what I don't know, and then I just put in the A and the C that I did know. That comes out to be a minus 400. I added it over, and then I took the square root. And so when you square root 400, you get plus or minus 20. So this would have two solutions. For B, it'd be 20 and negative 20 would be the values that would give this one solution. And I talk a lot about graphing things, but just as like a reminder here, this is a really good strategy for when you're taking this test, just in general. Things that have equations, like this and this, we can graph them and see if they're doing the thing that we think they're supposed to be doing. So let me just take a quick little time out here and show you exactly what I'm talking about, because you can get a whole lot of problems correct by understanding graphing. All right, so if I'm talking about this one, I think 20 or negative 20 works here to give this one solution. So I'm just going to plug this in with 20 in for my B value, and I'm going to see if the graph does what I say it's doing. So if I put in 20 for my B and I graph this, this should only cross once. Perfect, and it does. You can see the vertex sitting right there. If I switch the equation to negative 20, because that's what I'm saying the other solution is, it should do the same thing, just probably in a different spot. Yeah, right over there. So again, we see that's a one solution. If I did this problem wrong, let's say I didn't know what I was doing and I thought the answer was minus 400. I stopped at like this spot. Let's say I thought it was 400. If I graph this, it's probably not going to be anywhere on the graph. It's going to be gigantic, but it's not on here. And if we zoom out, we're going to see it's not where we want it to be. So these are things you should be doing if you're getting answers, to check answers, to do things. You have ways to graph stuff, whether it's your calculator, decimals, whatever. You can use it to help check your answers. So keep that kind of stuff in mind. With this one, I was asking myself, does this equal 12? I could actually just graph these separately. I could look at this and I could say, okay, I got the 5x squared, the 20x, the plus 4, and I want to know, does it equal 12? So now when I graph this, I'm going to have to change. I'm already zoomed out, so I'm going to change my window. But there's the path of the ball. There's the 12. So boom, hits it twice. Easy peasy. Like, don't overlook graphing things. Don't just panic if you don't know how to do a question, because you can probably graph it and figure some stuff out. Which leads perfectly to this. This says determine the number of solutions to this. I went ahead and I graphed it. So my graph in my calculator looked like this. I saw it cross twice. So I was like, boom, it's got two solutions. Then it says, what are those solutions? It does say do substitution. So I showed the steps there. So substitution, since these are both equal to y, you can see I just set the two equal to each other. Then I moved everything to the left because I wanted to get it in like standard quadratic form here. And then I noticed it just factored really nicely because C is negative 7. I found that negative 7 and 1 would give me the negative 6. And so my solutions were 7 and negative 1. So that's where I got those. This problem also can be solved by graphing in the calculator. So let me just show you what I mean. If I wanted to solve this, I wanted to get those same solutions, I can go, even just from the start here, if I put in the two equations that I have, I put in the x squared plus 8, and I put in the 6x plus 15, I can graph this and I can look for their intersection points, which should happen at 7 and -1. So the -1 definitely looks like it's right there. I go to my table if I want, and I can look and see, yep, at -1, they were the same. I can see at 7, yep, they were the same. Completely checks out, okay? Could I also get it from the graph? Absolutely. I can do the intersections where I go second calc, pick intersect, and then you just move your cursor. So one of them's right here. You hit enter 3 times, and boom, it gives you that coordinate. So you can use decimals where you just click on them. Whole lot of ways to do this correctly. I was actually exactly what 47 is talking about, so I can just run you through that one too. It says take this equation and solve it using your graphing calculator. So if I put these in, like so, okay, I can graph it, and I can find the intersections on the calculator. I think I might go standard window here because we're pretty crammed in there. So we'll go standard window. And so we very clearly see two solutions. Those are the x values we got to find. So it's the same process. You go to your calc menu, you pick intersect. So let's say you want to find this one first. Cursor over, enter, enter, enter. And there it is. There's that 2.1. And then if I did the same thing over here, I'd get the -1.1. Okay. Definitely, graph calculator is your friend. Okay. Use it on the exam, and you can probably do really well.